Hey there. Welcome to CSCI1061 week 3, where we're going to talk about dynamic memory. This is going to be a longer video than usual because I'm not just going to go over the solutions to the lecture exercises, but I'm going to go over the whole lecture. Hopefully you're staying inside safe and warm amidst this winter storm. And today I'm going to go over the topics that we're missing from unfortunately not being able to be together in class in person. So, dynamic memory, what's it all about? Well, today we're going to go over dynamic variables, accessing using pointers, dynamic arrays, also accessing them using pointers, and functions that will modify these sorts of things. Now, the notes are available again here. I recommend reading through them at your leisure. Just to talk a bit about them, I'm going to go through the dynamic memory ones in detail, but we've already seen vectors actually. It turns out vectors are an example of dynamic memory that we've already seen. And importantly, what this means is that the word dynamic means changing. And so a vector, as we've seen before, can change in its size and its capacity. So this is an example we've actually already covered in terms of making dynamic memory work. But how does it work is something that we're going to talk about today. And so dynamic memory very often can lead to lots of mistakes happening, and sometimes the computer is not very helpful at telling you when there's an error. So if you're looking for some tools that might help, you can try this one. It's called Valgrind. It helps you figure out if there are memory issues with your code. It doesn't work in Jupyter, unfortunately, but if you are programming outside, you can always try installing this and seeing if it will work for you. But anyway, we're going to talk about dynamic memory. So let's dive into that together. Okay, dynamic memory. So far up to this point, pretty much everything we've seen with regards to, let me enlarge this a little bit, with regards to variables and data and memory in the computer is stuff that was assigned before the program actually runs. It's assigned actually at the time that you compile the program and you tell the computer, here's how much space I need to run my code. But it might be a case that you don't know how much. Maybe you want to have a list of numbers, and the size of that list of numbers is determined by the user. How do you do this? In Python, this is actually already dynamic for you. They just kind of hide that detail. But we're going to go into the specific differences in this course because C++ treats dynamic and not dynamic memory differently. Now, we're going to use two special keywords for this, one called new and one called delete. In fact, delete is kind of less important because it's sort of often assumed that delete's just going to happen by default when the program is over, so it's sort of optional, but new is very, very important. Now, there are other ways to handle dynamic memory, and so if I zoom to the bottom of this page, you can see that in, whoa, did not mean to do that. In C, which is the predecessor to C++, it did not have access to new or delete. And so the way that it actually allocated dynamic memory was using special functions called malloc, calloc, realloc, and free. And you can read up in these if you like. They work in C++, and you may use them, but I find them to be a little trickier, mostly because you need to know exactly how much memory you want to allocate. And that means you have to do some math if you, unfortunately, don't like doing that. Rather than handling these different functions, which are optional, you actually can instead just use new for everything. Now, I wouldn't recommend combining them. It's not necessarily the case that you can use new for some things and malloc for others. I would recommend just sticking with one. And because these are, I would say, maybe harder to use, we'll just be using new with this course. So, new. How does new work? Dynamic memory is allocated with this operator, and we say what type we're looking for. We want a new integer or a new character or so on. And if we want more than one, you can use brackets just like we use with arrays. So here's some code where I'm going to make a dynamic array of 5 integers, and there's going to be a pointer to it called foo. So I can access that just using star foo like we've seen with pointers before, or I can index foo at index 0. I can access the next one with foo of 1 and so on. It's just like an array, right? So let's see how this works in terms of memory. And it turns out there's a few important keywords I want to cover. Just for this example, I'm actually going to use Python tutor so you can see the difference. And so here's the code that I stole from the website. I'm just going to compare it to a few other things. We're going to compare it to a normal array. So a normal array of 5 integers. And we'll also do this with some variables. So we'll just have int number and int star number pointer equals new int. And let's just take a look at what happens when I run this. Now, over on the right side here, we see there's two things that are being separated. One is called the stack and one is called the heap. And these are important terms that you need to know. Stack refers to all the memory that the computer has now set aside because I've started running my program and the amount of memory that's in here was figured out during compile time. How much memory did I need? Well, shouldn't it have one for the number? It's kind of weird. Let's put in a number so that actually gives me some... so it actually gives me something in the stack. Yeah, there we go. That's what it should look like. I think maybe it was trying to outsmart me by being like, oh, you never assign number a value, so you don't need memory for it. No, I want memory for it. Okay, anyway. Number is an integer, so there is enough space in here to fit an integer. Number pointer is a pointer to an integer, so there needs to be enough space in here to fit an address. Our normal array of 5 integers needs to have enough space for 5 integers. And we have another pointer here that also is going to point. Our heap refers to everything in dynamic memory. Right now we don't have anything, so nothing is there. But as we run the program, that's going to change. We also, if you really want to look into the intricate details, you actually can look at them using either the memory addresses or the byte level data. So if I look at memory addresses, I can actually see here is the address of all the information here. Here's the address of everything here. Each of these has a different address, and this has an address. And if you really want to get all the way down to how many bytes are in all these things, you can look at the byte level data and see, look, there's 4 bytes here. Here's what each address is. There's 8 bytes here. Each of these has 4 bytes. And then there's 8 bytes here. And maybe I'll come back to this just after we've run everything to see what it looks like. But most of the time, you don't need to look at that level of detail. But it's important to know how it works. So let's see what happens as I go through one step at a time of the code here. First off, I set my number to be 5. My number pointer is going to have a new integer. And when I run this line of code, what happens is space for a single integer is assigned in the heap. This area of memory is separate from where the stack is because I didn't know necessarily that I was going to be running this line of code that's going to assign all of this memory. And so the space that it's assigned in is called the heap. This is where all the dynamic memory is going to show up. And my number pointer, the pointer itself is inside the stack. I knew when I compiled this code, I would need a pointer of 8 bytes to point somewhere in the computer. But that place in the computer, I didn't know where that's going to be right away. It isn't until I actually run this line to make the dynamic variable that it actually puts that spot together. Now, my normal array already has space for 5 things. I suppose if I really want, maybe let's go and put some numbers in it just so that we can populate it. For I is 0, I less than 5. Just put numbers 1 to 5 in it. Normal array I equals I times 10. Sure, why not? Just so we have some actual numbers in there. In fact, maybe we should do that with everything. Sure. Let's actually populate some stuff. So I can do the same thing with my dynamic array. We'll do times 100. Why not? And for my number pointer, if I want to, again, this is a pointer. So if I want to put a value into the thing that's being pointed at by the number pointer, I need to say what's at the number pointer is going to be, let's say, 11. Okay, let's do this all again. Okay. It's getting really long. I'm going to shrink it a little bit just so I can see everything. Okay, that should be good. So, my number is 5. I have a pointer to a new integer, and if I assign the value 11, that 11 goes over here. Now I go through a for loop that's going to go populate this array. It's got 0, 10, 20, 30, 40. When I make a dynamic array, you can see that the space for that dynamic array is assigned in the heap. Over here, I have my array of 5 things. It's not in the same place as the stack. And the reason this is super important is because it could be the case that, I put in 5 here very conveniently, but maybe it's the case I wanted actually to ask the user how many numbers should I make, in which case this could be a variable. It could be anything I want, really. Now, something else to note is inside this loop, I have a variable I, and I doesn't actually get set up. You notice it didn't actually appear. It was hidden until this step. Why is that? And why is I not dynamic? I mean, it didn't show up until I was running the code, right? Well, because I is only actually present, it was only within the scope of the program inside of the loops, the space for I, although it's set up inside the stack, doesn't actually get used unless I'm in the loop. So now that I'm in there, I is going to be present. But I knew for a fact that I was going to have some variable I when I compiled this code. I also knew that I is only going to matter if I'm in a loop. If I'm outside of a loop, I doesn't even exist, so I can't access it. So I'm going to populate my little array, and hooray. Now let's look what this looks like at the byte level. So memory address wise, you can see here that the addresses over here, you can see they all start with triple F, and they're all kind of go up one by one. Not exactly, but they're somewhat similar. And if you notice over here, they start differently. If you maybe the font's super small, maybe you can't read it. I'll zoom in a little bit. You can see they start with 5C7 and stuff like that. So you can tell that the overall block of memory where the heap is completely separate from where the stack is. And knowing the difference between the two of these is the essentially main lesson of dynamic memory. If you really want to look at the byte level, you can even see into more detail. Everything here is all triple Fs. And some incrementing things. If you really want, you can actually go and see, where do they all start? Where's each one follow from the previous one? And the values that are in here, which no longer are question marks, actually represent the bits themselves. You can actually see, here's the ones and zeros of the computer in the specific locations. And so it's kind of neat to see that. And then this is the hexadecimal value of these zeros and ones. So OOA here, for example, if you're familiar with hexadecimal, you would know that this actually means the number 10. 1-4 here is not to be confused with 14. This doesn't say 14. Anytime you see OX, this means hexadecimal, which means it's not OX14, it's OX14. And hexadecimal, hexa meaning 6, decimal meaning 10, means everything here works in terms of 16s. So 1-4 means 1/16 and a 4. What's 16 plus 4? It's 20. So you can see over here, for example, this is not 28. This is 2/8. 2 times 16 is 32, plus 8 gives me 40. And so that's where all these numbers are coming from. And then you can see over here that the addresses of everything is once again the 5C7s, and we get our own little bits and bytes and so on. So neat to be able to see all this stuff in detail, I think, and it's worth knowing why these things do what they do if you want to understand dynamic memory. Okay, so let's go over back to where we were. I don't think we're going to use Python Tutor again, but it's important to know the difference between the stack and the heap, and you can visualize it here. But because Python Tutor is very slow at compiling, I don't recommend using this for actually coding stuff unless you're trying to figure out what went wrong at some point. I would stick with Jupyter; it's a lot quicker. So back to where we were. Let's see if there's anything important. It can be the case sometimes that you try to allocate more memory than you have. So there are possibilities for failures, in which case exceptions are thrown. We're not going to talk about exceptions just yet. We will later on in the course. But note that it is possible not only to mess up if you're trying to allocate memory you don't have. So you try to get a trillion integers. You probably can't. And so something will happen. And there is some stuff you can write to handle that, but this is, I think, less important. Okay, now, when you've allocated memory dynamically, it all sticks around in the heap, and it's just going to stay there till the program is over, but you may want to do so prematurely. Maybe it's the case you want to keep your code really, really efficient and limit how much data is sitting around at any given time. Turns out you can do that with just the word delete. So you can say delete pointer, whatever the name of your pointer variable is, and it will delete the data at that pointer. You can use the brackets if you want to delete everything in the array at that pointer. So here's some code. I guess we can try to run it and see what happens. I suppose we can do this with we can do this with Python Tutor. Maybe we'll see how it goes. Hopefully it compiles. We'll find out. Actually, no, this might not work because it does have cins. Does it let me handle cins? I'm actually not sure if Python Tutor lets me type stuff. Yeah, okay. So I can't run this in Python Tutor because I have to type something, and, so that's no good. It's okay. We'll run it in Jupyter and see what happens. All right, let's go. Okay, lecture 3. That's where we are. So let's make a C++ file. We'll call this one c++.com.cpp. Here's the code. Let's compile it. Maybe a good habit to start getting into is actually to not compile everything as a.out, just because that does get a little messy over time, especially if you're trying to compile multiple things. And we'll learn in a few weeks, actually, that there are some tools that we can use to make things really quick to compile over and over with better names. Well, we're going to compile this one to execute. Why not, just for fun? Execute. Okay, how many numbers would I like to type? I would like to type in 4 numbers. Cool. Enter a number. 5,000, 4,000, 2,000, -7. I have entered those numbers. Okay, cool. Not super exciting. Let's look at the code. Let's see what's actually going on over here. So, breaking down what's going on. So, here are some variables. We have I and n, which are normal variables. P is a pointer. How many numbers would I like to type? I get that input. And then I'm allocating memory for I numbers. Now, here's an interesting thing I've noted is that modern versions of C++ sometimes will automatically, without the new keyword, allow you to run this line of code, and sometimes it can work. Sometimes it won't. It's recommended to use the new keyword anytime you are doing something with dynamic memory to ensure that you're going to set up a dynamic array. In any case, there's some code here to handle what happens if it goes wrong. This is a bit optional. I don't think it's necessarily going to be a problem. Otherwise, we get to type in some numbers, and it outputs all the ones back to us and then deletes the array. So if I want to see what actually the array looks like after I'm done, I think it's possibly the case that the numbers are still there. Let's find out just for fun. We're going to cout p of 0, and we'll see if that works or not. Just out of curiosity. One of the best ways to learn stuff in this course is really just to experiment and see what happens. Okay, 4 numbers, 5,000, 4,000, 4,000, 7. That number. What the heck is that? Well, turns out it does actually look like when I ran delete with the brackets p, the computer decided to free up all of the memory in the computer, which was being allocated for my 4 numbers. As soon as I did, it needed that, I guess. And so C++ notably does not restrict things that you probably shouldn't be doing, such as accessing data that's been freed up for some other use in the computer. And so I was able to actually access something I probably shouldn't be able to access, which is whatever value that area had changed into. It used to be 5,000, now it's 164.22799793 for whatever the computer is doing. The server that's running all this code could be doing all kinds of stuff right now. I have no way to know. So, with that being said, once you've deleted something, you probably should not access it anymore. If you want to reassign more data, you need to use the new operator once more. Okay, so let's go back and see if there's any more stuff to talk about here. Okay, not particularly. That's okay. Let's dive into our examples, perhaps. Okay. Let's grab this code. It says use Python Tutor. We'll see if that makes sense to do. If not, maybe I'll delete that. Might delete later. I don't know. We'll see. Okay. Example 1. So, example 1.cpp. Comment this. Use pointer variables to point to a dynamically created integer in a dynamic integer array of 10 elements. Assign random values to each integer, output them, and allocate all the memory. And use Python Tutor for this. So, okay, we can probably do this with Python Tutor. We'll code it here and then throw it into Python Tutor once we want to see how the memory stuff works. But first, we want to ensure we actually can code it correctly. So lots of stuff written here. Let's break this down one at a time. As usual, we start with our favorite ways to begin a program, so that we don't forget. Main do. Okay, that's already there. Dynamically created integer, dynamic array of 10 elements. Okay, so dynamic integer, I need to have a integer pointer, int pointer, which is going to point to a new integer. I'm going to need to have a int array pointer is going to point to. I'm going to do it like this. I'm actually kind of curious to see. So over in our example here, yeah, okay, we assign that to be a pointer. So we're going to assign them both to be pointers, and this is going to point to a new integer array of 10 elements. Assign random values to each integer. Okay, so what's at the integer pointer is going to be a random number. Now I think Python Tutor might be angry if I don't include the C standard library to access random, so I'll do it like that. And also, just so I don't have a random number of a gazillion different possibilities, let's limit it to 100 different ones. And then for our array pointer, we'll go through each of the 10 and assign it, 0 to 0, to be a random number. Output them. Okay, so let's output them. Output integer pointer. What's at the integer pointer? The integer pointer has, and the array pointer has, and we'll output array pointer I. Oh, this should also be I. If anyone's yelling at the computer for me to fix that, I got it, don't worry. And a new line. Okay, and then deallocate all the memory used. So delete integer pointer and delete with brackets array pointer. And we'll see how the memory stuff works in Python Tutor, but I think this should be enough to run. So let's find out. G++ example.1.cpp.o example 1. Looks like it compiles. That's cool. Example 1. Integer pointer has a number. The array pointer has 10 random numbers. Okay, cool. Looks like I did it right in the first try. That always feels good. However, let's see how this looks in Python Tutor. PythonTutor.com. All right. Hopefully it compiles okay here. It should. I don't think it should mess up. So we got our 2 pointers that are in the stack, and all the numbers are going to show up in the array. So we got 10 numbers here, 1 number here. Our first one's going to be 83. Is that the same one that was over here? That's a freaky coincidence, isn't it? Hope the first number is not 86 here. I'm going to be very concerned. So the integer pointer has 83. The array pointer has. Oh, okay, no, I'm spooking now. Oh no, is it going to be? Is this one of those crazy horror scenarios? 86, 77, 15. Oh no, what's going on? I'm actually very, very concerned. I don't know why it's doing this. 93, 35, 86. But why though? Why is it doing this? Okay, I have to send this to somebody. I'm not sure what's happening. These should be random numbers. Oh, you know what it might be? It might actually just be the case that the first random number. Oh, because I forgot to seed it, right? I forgot to seed it. This is always very important. Seed your random numbers. Otherwise, you're gonna have horror stories like I just did. Okay, we gotta seed our random numbers so that we actually get random numbers every time. Let's fix that. C time is how we seed our random numbers, and we are going to seed random numbers with the time. If you forgot how to do this from 1060, it's okay. I forgot to do it in the first place. So it looks like I did make a little mistake here. Okay, now we can see. Okay, actually random numbers. I was a little concerned right there at the moment. It's like, oh, the reason that the random numbers are not actually random is because I forgot to seed them, so they weren't going to be random. Okay, So we'll fix this for next time. But in any case, okay, we got our numbers. So there they all are. And when we delete them, look what happens here. There's a little skull emoji just for fun. So skull emoji means that the pointer points to memory that's either unallocated, meaning we deleted it, which is what happened, or the boundaries don't actually make sense. So these are approximate, might not be correct. If you want to see details, we can click on the byte level, and we can see here this points to 5C7BC80, which is where the thing used to be. If I go back a line, you can see 5C7BC80. Maybe you can't see it, the font's really tiny. But then when that goes away, it becomes a little skull thing. And similarly over here, this becomes a skull thing as well, and everything in the heap is gone. It's been reallocated so the computer can use it for other things, because you don't want to limit what your computer can do with its memory. And that's that. So that was our first exercise, and fortunately I solved the scary, spooky, why did the two random numbers be the exact same in both times? And it's because I forgot to seed them. Always important to do. So your numbers are actually random and not just some numbers that you picked. Okay, so that was the first one. Let's do the second exercise. Okay, exercise 2. Write a function named momentum that will accept as arguments a one-dimensional velocity array with 3 values that are doubles, and a mass, which is also double, and return a dynamically allocated array representing momentum, and momentum is equal to mass times velocity. That's blown my mind already. I don't even know what I just read. But that's okay. Again, breaking it down into simple components will help us to solve the problem. Example 2.cpp. Okay. Write a function called momentum. Okay, so function momentum. It's going to return a dynamically allocated array. Okay, so it's going to return a pointer then. And the array is all double things. So it's a double star. Oops, I have this backwards. There we go. Double star. What's it called? Momentum. Has arguments a one-dimensional velocity array. Okay, so it's going to have an array of 3 values. Cool. And it's going to have a mass, which is also double, so we'll call that mass. Okay. So, now my function, I suppose I could do this in a notebook. I think I'll do it here though. Let's put our usual boilerplate stuff at the top of the code so I don't forget all this junk. Put this over, not in the main, because that would be weird. We do want to make sure it works, so we'll test it in a little bit. But first, okay, we got a dynamic array. We're going to need to make a dynamic array, I should say. So let's make a dynamic array that's going to represent the momentum. So the double star result is going to be a new array of doubles of size 3. Because what we're doing is we have these 3 velocities, and we're going to multiply each one by the mass, and that should give us our answer. And we need a new array to put it in. Okay. And I think we can actually do this pretty quickly. For I is 0, I is less than 3, I plus plus. So what I want to do is I want to go through my array with the 3 values, and I want to multiply each one by the mass, and I want to put those in my result. So my result at index I, which is going to go from 0, 1, and 2, the 3 different numbers, is going to be equal to the array at that index multiplied by the mass. And I'll return my result. Now to make sure this works, we're going to write some code in our main function to test it. This is an important thing to learn, I think, in computing, is knowing not only how to write a correct answer, but also how to make sure that your answer is correct. So let's work on that together. We're going to, first off, make some stuff. We're going to need a, is this one a, so this one doesn't have to be a dynamic array, so this can just be a double array. That's fine. So we'll have our double array 3 equals let's say our velocities are 3.3, 4.4, 5.5. I hope this is the right formatting. I always forget how to do array formatting. It's kind of annoying. Let's double check. G++ example 2 to example 2. Is that the right format? No, I messed it up. Oh, I also put the brackets in the wrong spot. These brackets are supposed to be over here. Let's try that again. Okay, now it's happy. Okay, so I got my array of my 3 velocities. I guess I should call this velocity, huh? Can I do a refined replace? I'm actually kind of curious. Oh, I can. That's cool. So I can replace array with velocities. Replace them all. Cool. That's handy. I'm still learning stuff about Jupyter sometimes, so it's neat to see the stuff that I can do. Okay, I have my velocities. My mass is going to be, let's say, 0.5. We're going to have everything for its momentum. Why not? So the velocities are, we'll go through each of the velocities. Velocities I, and then a space. Then we will do the mass is with the mass. And then we will get a momentum. So our double star momentum. Now I gotta be careful. I don't think I want to write momentum as the name of the variable. I suppose I can. It might just get confused. Let's see if I get an error out of it. I probably will, but double momentum equals momentum velocities comma mass. And then I'll see if I can output that. The momentums are momentum. I think this will be angry and it'll complain that I called a variable the same as a function, which I really shouldn't do. Let's just not do that then. We'll call it sure. We'll do momentums, plural. There we go. Momentums. There we go. All right. Did I make a typo? Let's find out. No, seems like I didn't. Does it run? Looks like we did it right, actually. The velocities are 3.3, 4.4, 5.5. The mass is 0.5. And having all of these gives us the correct results. So, hooray, we did it. Looking back here, we needed to use a dynamic array to create our result here. And we were able to pass a non-dynamic array. Did we look at... Yeah, we looked at that in Python Tutor. I think we can look at this in Python Tutor as well if we really want. Sure, why not? It's always good to understand why your code works, because if it works but you didn't get why, then you didn't really learn it. So our velocities got our mass. Our velocities are printed out up above, over here. We go into momentum. Now notice that the variables that are only part of the function while we're inside the function are still in the stack. So my double result here is inside the stack. It's not in the heap. But the actual result over here is inside the heap. This is the dynamic part, the dynamic array that I have. Nothing else is dynamic here. So I assign those values, and I return the result. And so now, momentums points to this part in the heap that didn't disappear when I left the function. This thing in the heap sticks around until I choose to delete it. And in fact, I didn't choose to delete it, so it stays around until the program is over. you see I never get the little skull emoji. So probably I should properly delete it when I'm done, but it's, again, sort of optional. Just to be really formal, I'll delete it. Momentums. And there it is. Okay, so that's example 2. Let's do example 3. Write a program to determine the average momentum of a collection of items with random velocities and masses. Include a function to generate random velocity arrays and use my momentum function with random masses to save my collection as an array of pointers. Whew, that also sounds really complicated, but we'll just break it down. Okay. Let's make a new file called example3.cpp. Okay, here's what I have to do. Here is the momentum code I've already done. I'm going to hold on to that and my int main. Actually, let's hold on to all of this. And then we'll see what we have to change. Okay, so I got my code from before. Determine the average momentum of a collection of items with random velocities and masses. Okay, so we're going to do a few things here. First off was we need an item. We don't have an item yet. Let's make an item. So since our item is going to have a random velocity and a random mass, what I think we want to do actually is I think we want to make a class to represent an item, and when we construct a new object of that type, we're going to give it a random velocity and mass. So first things first, we need a class called item. Our item class is going to have, well, we're going to not use great object-oriented principles just yet because we haven't really learned them super well. I'm just going to make everything public, but later we'll see this is not the best way to do it maybe. We're going to have a double velocity of this item, and we're going to have a double mass. Okay, and we'll also have a constructor called item. And let's make our let's say, for the sake of our I think I might need to build this separately just because I think that it might take a few lines of code for my constructor. So let's do item. Here's our constructor code, and what it's going to do is it's going to set this velocity to be a random number from random 3-digit number divided by 10.0. This way we get an actual double. And I'll do the same thing with the mass, actually. I should just make the mass smaller. The mass is only going to be... I'll make the velocity smaller. The velocity won't be any bigger than 10, but our mass can be pretty big if we want. So now we have a random... we have an item. It's kind of a weird question. Maybe I should have rephrased this differently, but it's okay. We're going to just do as much as we can. I feel like that's the best way to learn some of this stuff anyway. So, okay, we got items. We want to make a collection of items with random velocities and stuff. So let's do that too. We have some code here. Let's make our collection of items. So, in fact, we're going to go real ham, and we're going to ask how many items we want, just to be really cool. So, how many items do you want? Int item count. I'm going to read what they wrote into the item count. Yep. Okay, so for I is 0, I is less than the item count, we're going to make items. Now, here's where the new keyword comes in again. If I don't use a new keyword, I'm going to be overwriting the same item and over. This is kind of useless. I want to make lots of items. So every time I want to make an item, I'm going to make a item called new item equals a new item with the constructor. And then I need to put that in an array. So if I want to have a dynamic array of these items, then I'm going to need to make such a thing, which is going to be an item pointer to an item array, which is going to be a new item array of item count items. Just to repeat, my item array is a pointer, like all arrays are. It points to items, and I need to dynamically make an array that's going to fit them all. For each one that I want, I'm going to make a new item. And just so that we know this works, let's actually print them out. Here are your items. So we'll have item I, velocity, sorry, I gotta make the item first. Is going to be new item, oh sorry, this should be a pointer as well. Oop, there we go. New item's velocity, comma, mass is the new item's mass. This line is very long, and so to make sure that we're using good code styling, we're actually going to split it up, and I'm going to push this down to the next line. And end the line. Okay, I think this is a good place to pause for a sec. You should never code too much without making sure what you've done so far works. So let's save this. We've added in items. We made a constructor for it to make random sizes, masses, and velocities. And we're going to make sure that those are all functional. Okay. G++, example3.cpp to example3. Made a mistake. What did I do? I use this dot, but it should not be this dot. It should be this arrow. And the reason I know that is because this font's a little small. I can zoom in. Can I zoom in a bit? It doesn't seem to be letting me. Let me see if I can change the font size. Increase terminal font size. Yeah, do it again. Do it some more. There we go. That's what I'm looking for. Maybe you meant to use the arrow. Always, oh, my face is blocking it. There we go. Maybe you meant to use the arrow. Always a good tip that tells you that you made a little mistake there. Okay. Whoop. Okay. So, zoom in a bit. I fixed that. Let's compile it again. This is not a pointer. Right, because over here, these are not pointers. These are just values, so I should set them to be equal. Always good to, see these mistakes so you can know how to fix them. Yeah, it's not a pointer, it's just a value. Okay, seems like it worked. So this is my code from before. Give me 6 items. Look at that, here are my items, a bunch of them with random velocities, random masses. The masses are usually bigger, but not always. It's random, again. Okay, that's really cool. So I'm off to a good start, but that's just the beginning. So far what I've got is a collection of items that are random. Make a function that generates random velocity arrays, and use my momentum function with random masses to save your collection as an array of pointers. Maybe this doesn't actually match, I think, what the question is asking us to do. So you know what? I'm going to use my privilege as an instructor to change the question. So, function to generate random velocity arrays. What I think we actually want to do is make a function to generate velocity arrays, to generate a velocity array. Let's think about what might be interesting to do, We've made some items. They have velocities and masses, and we can calculate their momentum. How about we do the following? Let's start out with make a function to calculate the momentum of an item. Then make a function to generate well, do we need something to calculate the momentum of an item? I guess probably. just thinking a bit about, what kind of activities might be kind of cool with the code that we've got. We're building something here, so I feel like it's nice to actually, see some stuff actually in practice. Random masses to... I would like to make an array. Sorry. I guess we do have an array of items already, right? So, here's what we're going to do. Is we're going to... don't delete all that. We're going to make a function to generate an array of momentums given an array of items. I think that's a more interesting thing to do, right? Oh yeah, we never calculated the average momentum. We still have to do that too. Okay, so here's our to-do list. So to-do 1. Calculate the average momentum of our item array. To-do 2. Which actually should precede to-do 1, right? So this is maybe to-do 0. Make a function to calculate the momentum of an item, then calculate the average momentum of our item array. That makes sense. And then to do 3, or to do 2, I guess we're gonna do it in index order, right? Make a function to create an array of momentums from an array of items. I think that's a good place to stop, right? So let's rewrite the little question. I'm going to update the slides too. Hopefully people haven't been trying to solve them yet. Okay. So write a function. Here, we're going to rewrite it all from scratch. Why not? So these are the 3 things I think would be cool to do. In fact, we got to do -1 is the thing we've already done, which is create an item class with momentums and with masses and velocities. A mass and velocity. There we go. Okay, so create an item class that has a mass and a velocity. Overload your momentum function to calculate an item's momentum. Calculate the average momentum of an array of items. Finally, make a function to create an array of momentums from an array of items. Okay, we're gonna change in the parameters, and change the rules, as they say in Star Trek. Is Kobayashi Maru. If you have no idea what I'm talking about, it's okay. Okay, we changed the rules of the game. So I think this is better anyway, because it gives us a chance to practice a few different things. So let's do all this stuff. Okay, this done. Check. We did it. Number 2, make a function to calculate the momentum of an item. So we're going to call that momentum as well, but it's going to be a little different. So this one is going to be double star momentum. And it takes an item. We'll call it, my item. Sure, why not? Okay, and it's going to calculate the momentum of that item. And it's going to return, in this case, just a double, I think is fine, right? We don't need an array of momentums out of this. We just need a single one. So we're going to return my item's momentum dot momentum, or dot mass, times my item dot velocity. That's pretty simple. Okay, that didn't take us very long. And notably, because the parameters here are different from the parameters up here, anytime we call momentum, it's always going to use the right one because we know which one we're calling it from. Okay, so cool. We got our momentum. In fact, maybe we should, just for the sake of consistency, make sure that these both return double pointers. So actually what we'll do is we'll make this return a new double. Let's make a new double first. So double star result equals new double, and result equals this, and we'll return the result. Not a big difference, but just so we can use our dynamic variables. We learned how to use them, so why not use them, right? Okay, so we got our momentum. Now, what we're going to do is, we got our function to calculate momentum of an item. Check. Calculate the average momentum of our item array. Okay, so we got our item array down here. We need to calculate the average momentum. Let's do it with a function, right? And our average is going to be a double. We'll use a non-dynamic variable this time, though. We'll just calc average momentum given a array of items. Do we make a... So this is a dynamic array, so we're going to pass it a pointer of items. Now, we do need to know how many there are, so we're actually going to have a second parameter here, which is going to be the item count. We do need to know the item count, otherwise we're going to have a kind of hard time figuring out how many are in here. Okay, so we got our item count. We are then going to calculate the average momentum. So to do so, we need to calculate an average. So first off, we need our sum, starts at 0. We're going to need our... well, we already have our item count, so that actually makes it really easy. So now we just need to add everything to our sum. Basically, the average is we have to sum all the momentums together and divide by how many momentums we have. We know how many there are because it's how many items we have, so we just need to add all of them up. So for I is 0, I is less than the item count, I plus plus, sum plus equals, item, what is it? What's at the momentum of items I. That's a little spooky bit of code for me to feel like I'm writing, but so this is something where I want to again double check that what I'm doing is right. So I'm gonna put in some code here to check it. So we're gonna calculating average momentum. Should always fill in lots of print statements to make sure your code is doing what you think it should do. Okay, so current sum. We'll do it at the end of the calculation. So the current sum is the sum. We'll do the current momentum too. So current momentum is the result of this. Make sure that that's actually being calculated correctly. And we get our sum. We should get the sum and momentum be changing every time. At the end, we will return the sum divided by the item count. And because this is a double, it should give us the actual correct answer. And then we can also check down here, the answer. So we are going to the average momentum is, and then we have to run this function, calc average momentum, given our item array and our item count. All right, lots of code that I've written, so let's make sure it actually does what it needs to do. All right, what did I mess up? Cannot convert double to double star. So this is because over here, my item.mass times my item.velocity is not doing what I need. Over here. So my item.mass times my item.velocity is not giving me... because I'm trying to assign that to the address of the pointer, not the value. So so here's what happened. I saw what's going on here. I knew this line of code has the problem, and I tried to figure out what's the problem. And it mentions here cannot convert double to double star. And what usually this means is that you missed a referencing operator at some point. In this case, I missed a star somewhere. So where did I miss the star? I go to that line and I see, okay, what's going on? My result is a pointer. It's supposed to point to a dynamic double variable, and I forgot to put the star there. And so what I was accidentally doing, which I shouldn't be doing, is assigning the value of the pointer, which means the address that it has, to be my calculation. But I don't want that. What I want to do is go to that address and put in there the calculation. Okay, so that should fix that problem. Go. And go. How many items do I want? Give me 10. Okay, so we got some items. Here they are. We calculate some momentums. I sure hope the momentums are correct. Did I calculate them correctly? Momentums looks really big. 736, 735.8, 0.38. That's really big for mass of 3.6, velocity of 1. So that seems like something weird is going on. What is happening? Let's try to see if we can figure it out, because I don't trust that at all. So. You know what I did? Is I forgot to put them in the array. So clearly, some weird stuff is going to happen. So I should do that. Item array I is the new item. I think that will help. No, I think I may have to be careful with double pointers here. Let's see. This might give me an error. I think it'll give me an error. Yeah, okay. So here's the problem. Is I have an array of items, and I've made a dynamic item here, but I don't want to give it the an address. I want to put the actual item in. So here I need the asterisk once more. If you caught that, then good. And if you didn't catch that, that's maybe a sign that you want to double check that you know your pointer stuff, because it's a common mistake to make, because I just made it. Okay, that fixed it. Let's see if this works. Give me 10. Okay, this looks a little more reasonable. Yeah, okay, here we go. So now I know it. Now I have confidence it's actually working. And the reason I was concerned before is because when I looked at the numbers here, 36.8 times 1.1. Oh, it looks like I forgot to seed it, so I should fix that too. Is going to give me about 40. And if I looked up from above, it was giving me 700. That's clearly not right. So the second time I run it, I can see, okay, now it's actually multiplying everything together. What I was doing before is because I hadn't actually put in the items into the array, it was grabbing random numbers and then multiplying them together, doing some weird stuff. So that's not great. Okay, now, last thing that I want to do is I want to free up all my memory, because I definitely allocated a lot. And I want to... was there another to do that I forgot? Oh yeah, create an array of momentums from an array of items. I forgot to do that. So this is done. Create my average momentum from an array of items. I can do that. Now I need to make a function to create an array of momentums from an array of items. So we're going to need to make a new... and this is an array of momentums. So this is going to be a double star momentums array, I suppose. But yeah, I should call these like by better names. So it should be I think this should be calc average momentum without the underscores. Yeah, that's better. And this is momentums array. So given an array of items, items star items, and the item count, I'm going to return an array of momentums. Okay, so now this shouldn't be too hard to do. I can steal some of my code from before. So for each item, I'm going to need an array to put this all in. So I'm going to need a double momentum array. This is the pointer as well. Is a new double array of item count elements. And I'm going to put into that array the momentum of item number I. And then return it. Done. That's a quick one. Again, should always make sure this stuff works. And also let's clean things up now by deleting everything we need to delete. So probably what we'll do at the very end of this all is we're going to delete the item array for sure. We already deleted our momentums, and I think everything else actually will go away already, so that should be fine. But we are going to need to make our momentums array, and we're going to have to delete that too. So we got our average momentum. Let's get our list of them too. So we got our items. Now let's get our array of momentums. Maybe actually it's better to do these in the reverse order. So yeah, you know what? Our our to-dos. Here, I'll switch it for anybody who's doing the exercise outside of it. But let's flip these around. This should go here. Make a function to create an array of momentums for array of items, and then finally calculate the average momentum of an array of items. So now this makes a little more sense, right? Because I think if you make the function that makes an array of momentums, then it's easier to calculate the average, right? Because you can just take the average of the array. We did it the hard way, but that's okay. You know, we're doing this all together. No rush, I suppose. So okay, let's wrap this up with our last function we're going to write today, which is, well, we got our momentums array function, so we need to make a double star momentum array equals momentums array. That's what it's called, right? Momentums array. Yeah. Of our item array and our item count. To make sure this worked correctly, we're going to go through it. Boop, boop. We're going to output momentum I is momentum array I. Okay, let's see what happens. I'm writing a lot of code today. Okay, what did I mess up? Another pointer issue. 56. Okay, what did I mess up in 56? So momentum, yes, again, returns me a dynamic variable, so I need to get the value at that dynamic variable. Okay, try that again. 95. Calc average momentum. I called it the wrong thing because I changed the name, so it should be a calc average momentum. Okay, let's fix that. It's very handy too. It tells me, did you mean this? Yes, I did. All right, no errors. Let's try to do that again. Give me 10. All right, let's see what happened. Here are things. Here are momentums. That seems about right. I wrote the average momentum is twice. That's a bit of a typo. So I don't think I need to do that. In fact, I actually could probably just call calc average momentum, right? What is average calc average momentum is? Oh, you know what? So I should assign the average momentum to a variable. I think that's a better idea. So double average is calc average momentum. So the average momentum is the average. So don't mind if I'm going too fast. You can always go back and play it, but I will review everything with some comments before we wrap up today. So, okay, compile, good, run, great. 10 items, let's go. Here are my items, velocities and masses. Here are the momentums. All right, calculating the average momentum. We add it all up, this number. Here is our average momentum, and we're done. All right, I think that looks good to me. Great, so what do we do in this last example? This one was like a very extensive one, so let's comment everything. Check, we did all the stuff, cool, okay. So, this program handles the items with mass and velocity and does some math with their momentum. The author is me, version 1.0, date 2023-01-25. I don't think I would expect this level of commenting from the average assignment in this course, like a lab or a test or anything like that, but in real production, this is the kind of thing you should write in all your code, especially anything that's more than like a really, really simple thing. Okay, so our item class. This class represents objects with velocity and mass. Doesn't really do much of anything. I could have perhaps made this, the only reason I didn't make this a structure is because I need to give it random values. So velocity is a random value between 0 and I guess 10.0, and mass is a random value between 0 and 100.0. That's what this math is doing down here. So I don't think I need any more comments there. That's pretty clear. Let's talk about this method. So yeah, should I write these comments above or below? I think I'll write these above, actually. It's probably better practice. Class represents stuff. This method calculates momentum given a velocity array of 3 values. Ideally, this is representing 3 dimensions. That's probably the intention. And the mass of the object moving that way. So probably if I wanted to like really perfect this, what I might do is actually say, because right now I made the velocity a single dimension for my class. I probably could make it 3 dimensions if I wanted to be a little more, interesting. But you know what? Maybe that's a to-do. To-do homework. Modify my item class to have the velocity in 3 dimensions. That is with arrays, with an array, and change the rest of the file accordingly. This shouldn't be hard to do. Maybe it's a little tedious, I don't know. But if you have trouble doing this, that's a sign that you need to practice. Okay. Yeah, what's in the mass of the object moving that fast? This one calculates the momentum of an item. Pretty straightforward. This one calculates the average momentum of an array of items. Another thing you could consider adding is also descriptions of what the parameters are for all these functions. I'll leave it out, but it's not a bad practice for sure. And this returns an array representing the momentum of each item in the items array, respectively. And this code is just testing. And I'll save all that. All right, I think that wraps up the video. I don't know how long this was, but it's a chance to do a lot of practice with some of these dynamic things. Another thing that you may want to consider is if you look back at lab 10 of 1060, which is one that a lot of students had some trouble with, I recommend making sure that you know how to do it using dynamic memory. And what I mean is that there are many students who solve this problem using static arrays with a large number. For instance, I'm going to make an array of 100 nodes. What happens if I want 101 nodes? Your code doesn't work. So try to make sure that you can reproduce lab 10 from last semester using dynamic arrays, using nodes that are created using the new keyword, and make sure that you can still implement a stack like that. We won't get a chance really to practice that kind of thing, I think, in this course, but it's expected you know how to do it. And after everything that we've covered today, you should have all the tools you need. So give it a shot. As always, it's always good to practice this kind of stuff. Even after watching the video, it's not a bad idea to try to then solve it yourself without copying the code. Probably the worst thing that you can do is watch these videos and not actually try anything. Don't take these videos as a chance to do nothing. Make sure that you're actually giving yourself the opportunity to make sure that you can code these things, because if you can't do it yourself, you won't be able to reproduce it on a test. You're probably going to have some troubles. So give that a shot. That's my recommendation. Thanks for watching this video. Hopefully you're staying safe inside and having a nice day. Take care, everybody, and I'll see you next week in class. Bye-bye.